Hello, we are continuing factoring. This is going to be pretty similar to last time, but we're going to learn another step so we can factor even more types of quadratic expressions that we can do before. But it's overall pretty similar to what we did the first worksheet. Um, if you're feeling good about that first factoring worksheet, then this should be pretty chill. If you weren't feeling good about it, then I would definitely revisit it and practice it more. Um, So, what is a quadratic? This is just a bit of review. Quadratics are these expressions that have x squared terms. In Algebra 1, you're mostly doing stuff with like this, but now we're doing stuff with ones of x squared. Um, and what is a factoring? Factoring is like the reverse of distributing. So when you're distributing, we're going from the state where we have these like two smaller expressions that are multiplied together to just one big expression. In factoring, we're going back to this state um, with two like expressions being multiplied together. Um, so last time we were doing ones where the coefficient of x squared. Coefficient means the number in front of it. So like this number, we're used to doing it with one or numbers or well one. It's always an invisible one, but a one. But now we're going to learn how to do it when it's not one. And when it isn't one, it's harder cuz it's just rough. So we're going to be sad that it isn't one, but because we are sad, that means we have to make it not one. Um, so we're actually going to do, before we do that other factoring that we're doing before, we're going to do another little factoring thing, which is basically undistributing. We're doing the opposite of distributing, and we want to undistribute this 3. Um, we want something where it's equal to 3 times some expression in some parentheses, and that will make our lives a lot easier. Let's do that. So, once again, we're trying to get it to a point where it's 3 times an expression in a parentheses, which is going to be this. It should be the same thing as what we started with. So we're going to undistribute, aka factor, and you can notice pretty quickly that it's basically going to be the same thing as before, but we divide by 3. And like here we have 3. We're going to pull that out. If you want, you can think of this as a 1. It's an invisible 1. 3 divided by 3 is 1. 6 divided by 3 is 2. And 9 divided by 3 is 3. Or I guess negative 9 divided by 3 is negative 3. So now we get this thing. These two things are equal. Let's just, you know what, I won't. But you can just distribute again, see that they're equal. And pretty quickly you'll be able to figure out exactly what it's going to look like when you're pulling out this 3. Or factoring out this 3. Great. So now we have something here that looks, now this is very similar to what we've seen before, where we just have an x squared here and we know how to factor that. A little review, you ask what two numbers when you add together get to 2 but multiply to negative 3. So let's think of the numbers that multiply to negative 3. I think it's just, for whole numbers, it's just negative 3 and 1, and 3, negative 1. And which ones add up to 2? These two add up to 2. Oh, I did this wrong, actually. Wait, no. Wait, yeah, I did this wrong. Whoopsies. The signs were wrong there. So yeah, we know how to, so you, once again, the two numbers I underlined before is 3 and negative 1. And then you put that into something that looks like this. So now, like, as you see here, like this thing, we've now factored it, how we were doing it before, into this. And then, like, really, you can also just, like, get rid of these two parentheses because why? So here, there's, like, these three things. You can really think of these as these three things. You definitely need these parentheses because you're separating this from like this. You're like, this is its own entity. That's why it needs parentheses. And basically we're multiplying these three things together. And it turns out doesn't matter what order you multiply things in. So these parentheses are telling us that we should be multiplying these two things first. So this is by the way not very important. Well, I guess it's so I shouldn't say that. It's important. I'm just never mind. It's important. So these three things are being multiplied together, and these two parentheses over here are telling us that these two guys should be multiplied first, which is fine. But it turns out it doesn't, like if you're multiplying three things, 3 times 2 times 4, for example, it doesn't matter what order you multiply things in. So we can really just ignore these parentheses. They're telling us to multiply these two things first, but we don't really care. We can multiply them at any point that we want. So you get rid of the parentheses. Rewind that part if that's not super clear. It's not super important. I just want people need to understand parentheses. So I don't want to just do some hand wavy stuff. Let's just get rid of these parentheses. Because that when math teachers do that, then you guys just start to not understand what parentheses are. Let's do some examples. This one. Okay, so there's this 2 here, so I'm sad. So let's factor it out. So we're gonna like undistribute the 2. So 2 times what is 2x squared? That's x squared. Because if I distribute this, we're gonna get back to here. What would I put next? I would put, well, 2 times what is 8x? That would be 4x. 2 times what is 8? That would be 4. Cool. Now this part we know how to do. We ask what 2 numbers add up to 4 and multiply to 4. You can think of all the numbers that multiply to 4. I think it's 1 and 4 and 2 and 2. Technically they can both need negative, but these two add up to 4. So those are the guys we want. So I'm gonna replace this thing inside with this factored version. And once again, you don't need to actually add these 2 parentheses on the outside. Well, I've gotten better at writing. I'm still doing it slowly, but I've gotten better. There we go. That's your answer. So this first step here, getting to here is the new part, but it's honestly pretty chill. And then from here, you do the old stuff where you get to here. There we go. Let's do another example. This one's harder. So I'm sad that there's this 3 here, because I know what to do if there's not a 3 there. So I'm going to undistribute. I'm going to factor. I should... whatever. 3 times x squared is 3x squared. 3 times what is negative 12x? Well, how do I get that negative 12? I have to do 3 times something. 3 times, it has to be negative because it ends up negative. And 3 times what is 12? 4x. You can double check in your head if that works, and it works. And then 3 times what is negative 23? So it's going to be a negative for sure. And 63 divided by 3 is 21. Lovely. And yeah, once again, with factoring, you can always check if you did it correctly. You can just distribute again, check if it works. I know it's extra work, but you can, like on a quiz, you'll know, you can always check if you got the right answer. Okay. What next? Oh, yes. So we need to ask what 2 numbers add up to negative 4. I can put an addition if you want. And multiply to negative 27. Well, what multiplies to negative 27? There's like, it could be like 3 or 7, but one of them has to be negative, so maybe it's negative 7 and 3, or negative 3 and 7. Do either of those work? Well, these both multiply to negative 21. Do one of them add up to negative 4? Well, these ones add up to negative 4. So these are the guys we want. And then we're basically there. Once again, we don't need that many parentheses. We're just going to have something like this. And once again, if you're not sure about that second step, you can always just distribute again and check if you did it correctly. Yeah, hopefully that's not too crazy. You guys got this. We're going to be doing this a whole bunch, so make sure you're practicing it.